All right, so this is just a little video explaining the notes because I realize you might have looked at them and said, oh my God, that's a lot of stuff. So I'm just gonna break down each example and explain, just kind of what's going on. This first example should be pretty straightforward. It's just a lot of work, to be honest. I have what we call a composite shape because you'll notice it's made up of multiple shapes. This one is made up of a triangle, a trapezoid, and a semicircle. And so the first thing that I do when I need to find the area and the perimeter of the shape, I usually deal with area first. So I figure out a plan for the area. Now, when it's something like this where it's pretty easy to tell things are just being added together, the plan, I guess, isn't as important. However, when we get to things like example 2 and 3, you'll see why it's so important to make a plan of some kind as to what you're doing with the areas. So this one, because it's just a triangle, a trapezoid, and a half circle kind of stuck together, I know I just need to find the areas of those three things, and then I just add them together. So that's what I did. Step one is me finding the area of the triangle. I'm using the regular polygon formula because they gave me the apothem. And so I needed to find the perimeter. You'll notice because the apothem is 2 square root of 3, remember that in an equilateral triangle, this angle here is 60 degrees, so this one must be 30 degrees, which means that to get from here to here, I need to multiply by square root of 3, and if you do that, you should end up with 6, which means that the entire side is 12, and so I got the perimeter as being 36. I then just took those numbers, I put them into this formula, I simplified. Half of 2 square root of 3, these 2's just cancel, and so 36 times square root of 3 gets us here. I then moved on to finding the area of the trapezoid, so I wrote down the formula. I wrote down the things that they told me. We talked about this on 8.3, but when something's written like this, right, they're telling you the height. Because if they were telling me this was 10, they would have put the 10 right next to it, right? And so I was pretty much told all the things that I needed. We figured out that this was 12 from finding the area of the triangle. And so when you're using the trapezoid formula, just remember, you need to make sure that you always add the two bases together first, like I did here, and then divide by 2, and then multiply by the height. And so that's how I ended up with 150. I then moved on to finding the area of this semicircle. So I was told that this base of this trapezoid was 18, which is also the diameter of this half circle. So that means the radius is 9, because that's half of 18. And so I basically just, I took my radius of 9, I put it into the area formula for a circle, and got 81 pi, and then I divided it by 2. So then I was left with 81 pi over 2. And so because I did my little plan up here, I just replaced those areas that I found into my little plan, and that gave me the total area. And this is what your answer would look like if it's an exact form. If for some reason it told you to round to a certain place, or that's what would happen in this problem. They would have to say round to whatever. This would be the answer as a decimal. But also, if you do everything in exact form first, you don't have to worry about rounding error because you don't round until the very end. For the perimeter, though, a really good strategy is to highlight or in some way mark everything that's on the outside of the shape so that you know what things need to get added together. So that's why I highlighted the edges out in purple. We already knew this was 12 and 12. I had to use Pythagorean theorem with my height and this 3 here to get square root of 109, which, if you're wondering, remember that a trapezoid can always be separated into 2 right triangles and a rectangle. So because I knew this base was 12, I knew this from here to here was 12. So if the entire side is 18, that means that these must each be 3, because 3 plus 12 plus 3 is 18. And 109 doesn't simplify, so I leave it as that. And then to get the circumference of just this section, just like in 8.4, how we talked about, you just multiply the fraction by the circumference. The entire circumference of this whole circle would be 18 pi, but because it's half the circle, I multiply by 1/2 and get 9 pi. And so I get my perimeter as, after adding all this together, this an exact form and this as not exact form. Again, if it said to round to a certain place. Moving on to example 2, we have a pentagon inside of a circle, but notice only some of the slivers are shaded. So some things to take into consideration. In order to get the shaded parts, I do need the area of the pentagon and the area of the circle. If I just subtract the pentagon from the circle, I end up with the area of all 5 of these slivers. So if I only want 3 of them, right, because there are 5 parts in total, that's why we multiply by 3/5 here. So I figure out the area of the circle, the area of the pentagon, I take the pentagon away from the circle, that gives me the area of all 5 of these, and when I multiply by 3/5, that gives me just the 3 that I have shaded out of the 5. So I found the area of the pentagon without spending too much time, right? Because this angle's 36, I used trig, and you'll get about 7.99. To get the perimeter, 7.99 times 2, because that gives us the length of the entire side, times 5, because there's 5 sides, gives us this as our perimeter. So when I just replace those into my equation, I end up with about 439.56. Now, I'm not rounding in my calculator, so if you're getting numbers different from me, that's why. The actual numbers like 7.98, blah, 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 blah. It's really long. And then I found the area of the circle, but I didn't have the radius. So notice that the radius of my shape in this example is the radius of the circle. So I found the length of that radius using SOHCAHTOA and got 13.6-ish. So I put that into my area formula and got 580.79. Now recognize that I multiplied by pi in the calculator because I'm using trig in this problem, which means my answer has to be a decimal anyway. So I'm not going to leave pi in my answer because there's no point. And so then I took my plan and I just replaced the numbers in here. Now follow your order of operations. So I had to subtract these first and then multiply by 3/5, and that's how we ended up with 84.74. Now the last example is probably, the math itself isn't hard, it's just the plan in the beginning is kind of difficult to make. So you'll notice that the shaded region, right, if we think of it at first, is this half of the square, so this triangle, with this little sliver of the circle taken out of it, right? But then we run to another issue. We don't have a formula that just tells us the area of that sliver by itself. So I need to figure out what that is. And so that's why I thought about, well, how do I get the area of that sliver? Well, if, let's say this was my shaded region, notice that this is a part of this entire sector right here. So that means if I find the area of this sector and I take this triangle away, I will have the area of this sliver. So once I have that, then I can subtract it from this big triangle. So I found the areas of those 3 different things. So this is the area of this big triangle here. Because this is a square and this is a right angle, consequently, the area is just 10 times 10 divided by 2, which is how we end up with 50. To get the area of the sector, right, notice this is a 90-degree angle. And so because this is a right triangle, right, I just had to, I'm getting ahead of myself, wait. So 90 degrees means this is a fourth of the circle, because 90 out of 360 is 1/4. The area of the entire circle, if the radius is 5, which I know because this semicircle is within my square, so that means the radius is going to be half the side length, which technically this is also the apothem, but they're both radii. And so when I find the area of my circle, I get 25 pi. And so when I multiply 25 pi by 1/4, I get 25 pi over 4. I can't simplify it, so it stays like this. So same thing with the area of the smaller triangle being this. 5 times 5 divided by 2 is 25 halves. And so then I have all the pieces I need to figure this part out. So the area of the sliver, like we said, was going to be the area of the sector minus the smaller triangle. So the area of the sector was 25 pi over 4. The smaller triangle is 25 halves. And so we end up with this as our sliver. I want it in exact form, so I'm going to leave that alone because there's nothing else I can really do to simplify. So then I move on to the area of the shaded region. Well, the area of the big triangle is 50, and I subtract, it's really important you put this in parentheses, the area of the sliver, right? I want to make sure it's in parentheses because I have to distribute this subtraction sign because there's more than one expression, if you will, in here. And so when I do that, I end up here. And the reason I go ahead and I add these together is because I can, right? If 50 and this number, if they're over the same denominator, I can add those numerators together. So I want to go ahead and do that. I don't bother with this because even if I did make it the same denominator, I couldn't subtract it from whatever number I would get here anyway. So I leave it alone. And so this is what my area would be in exact form. I hope that helps. Sorry I couldn't be there. If you have any questions, feel free to come by tutorials, though this last example is definitely a more difficult example, and so I really do hope that you take the time to look at these. The homework overall is fairly short, so hopefully it doesn't give you too much trouble, but I will see y'all when I see y'all. Bye.